Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael, and in studio with us we have Luis. Luis, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everyone else 1-866-636-6284. Email dothemathkern.org. We are at Do the Math Online Net and on the social media, Facebook, Instagram, Twitter, and YouTube.
All right, thanks for that, Luis. So, Luis, where do you go to school and what grade are you in?
5th grade, and I go to Highgate.
So you go to Highgate, and Highgate is a brand new school, isn't it?
Yeah.
How do you like that new school?
It's good.
Yeah, you like it? Everything's nice and new and neat and clean, and
Yeah.
so it's pretty nice. Where did you go to school before Highgate?
Buena Vista.
And so you were a Bulldog for a while,
Yeah.
right? And Highgate, what? What's their mascot or whatever? The Highgate?
It's like husky and it's like bulldog.
Oh, Huskies.
Yeah.
All right. So 5th grade's going pretty well so far?
Yeah.
So what, you learned a little bit about some decimals earlier on this year, correct?
Yeah.
Okay, and then you're moving into fractions.
Yeah.
And you know about numerators and denominators,
Yeah.
all right? So let's do a problem real quick. You want to do just a quick, easy one?
Yeah.
All right, head on over to the board. I will let you, Luis, pick the first fraction. You can put whatever fraction you want up there. All right, so you did 3/6. So let's go plus, and let's go 1/3. Now, what do you notice first of all about those fractions?
Then unlike denominators.
Right, they're unlike denominators, right?
Mm-hmm.
So what do you think you need to do first?
Multiply them.
You want to multiply them? Okay, and what would you get then?
18.
All right, so explain to me what you're doing. So you multiplied 6 times 3,
Mm-hmm.
and you got 18.
Yeah.
Good, so what's the next step?
Then we could do 3 times 3. That equals 9. And then 6 times 1. That's 6. And then we that equals to 15. 8.
All right, and that's all there is to it?
And we could put 15, 8, and we could.
So what are you thinking about right now?
Making it smaller.
Making it smaller, so you're trying to simplify it? Is that what you're
Yeah,
doing?
simplifying.
Okay, so explain to me what's going on through your head. What are you thinking about?
Dividing it by 3,
All right,
and that is 5, 6.
so why did you divide by 3?
Because it's still the same answer because it's just in a different form of numbers.
Okay, so you know that 3 will go into 15 and 3 will go into 18,
Mm-hmm.
right? So both numbers are divisible by 3,
Mm-hmm.
and you just said it's a different form.
Yeah.
5/6 is simpler, right?
Mm-hmm.
All right, nicely done. So you've got a little grasp on the addition of the fractions right there. All right, nicely done. 636-4357 is the phone number, and the reason we want to let you know about that right now is because if you phone in today and we do one of your math problems, you will automatically receive a free pass to Holiday Lights at Com.
Holiday Lights at Com is back. Drive through this 3 million light extravaganza from the comfort of your car, all brought to you by Dignity Health. Enjoy countless colorful displays for the whole family.
All right, there you go. There's the information. You give us a call anytime between now and Wednesday, December 8th, and we do one of your math problems on the air. You will automatically receive a pass for your entire family to go in a car, and you will be able to enjoy the Holiday Lights at Com. So, Luis, have you ever heard of Holiday Lights at Com? No? Well, you know what? All you have to do is you call in sometime, right? You know how the show works, right? You're going to be here all hour, right?
Yeah.
And you call in and you go, hey, this is Luis. I was on show the other day. I'm a 5th grade kid from Highgate. I want to work on this problem. As soon as you work on your problem, you and your family are going to go to Holiday Lights for free. Not too bad, is it?
No.
All right, there you go. All right. And I'm sure your family will love you for that as well. Anyway, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, we are celebrating 20 years of Do the Math this year. And first of all, we are fortunate enough to be able to celebrate 20 years of Do the Math. There have been some previous math shows around the country and things like that, kind of got started. And I don't think anything has even come close to being on air for 20 years since we've started this. And all during this season, we are fortunate enough to bring back some people that were instrumental in the early years with Do the Math. And you might be looking at my guest today, Zane, and going, well, you've been on the air for 20 years, so he's like maybe 20 years old right now. How's he been instrumental from one big beginning? So that's what we're going to talk about. Zane, how are you today?
Good, how are you doing?
I'm excellent myself. So let's let everybody know, because when Mackenzie was on, it was kind of the same thing. It's like, how can somebody that young be part of Do the Math in the early years? So when did you first become part of the Do the Math program?
Well, a family friend of ours, my family, had someone working here in this building and mentioned the show to me because I had started making skateboarding videos with my friends. So I was interested in...
And how old were you then? Like, or what grade were you in?
I was probably maybe a freshman or sophomore in high school.
Okay.
And then I started doing the video yearbook at BHS when I was in high school. And I think I joined Do the Math in 2010.
Okay.
Yeah.
So it's been 10 years.
Yeah, maybe a
All
little
right.
over 10 years.
10, 11 years. So you heard about Do the Math, and what was the next step?
Contacting John and getting a tour and taking a look at what they did here. And next thing I know, I was working here my senior year of high school.
There you go.
Remember that.
And so you got a hold of John, and that's much in the way Mackenzie did, because you guys weren't on air as tutors because you're not math teachers, but we were able to incorporate students, and you and Mackenzie were the first ones to be able to come work on Do the Math. And Mackenzie led the way for producers, and you were actually a director.
Yeah, towards the last year I was here.
So what were your roles before that? Like, what were you doing at first, and then how did that lead up to being a director?
I was on that camera right there, camera 3.
Now, is that the one Mackenzie was on also? Because I think John, she also turned over there and was like, oh yeah, camera 3.
The least responsibility, maybe.
Okay. Well, you know what? Somebody's got to man it at that
that's
point.
true. That's true.
And you said that was one of the things you noticed when you came into the studio, that the cameras are different.
Yeah.
There's nobody behind them now. There's one person in the control room taking
They're
care
a
of
lot
it.
smaller too than the ones that we were
Right, they
working
are smaller. All right, so you started on camera 3.
Yep. And then if I remember correctly, camera 2 had the most movement, the most responsibility to gather the shot. And so I worked at the show, I think, for 4 years, maybe almost 5.
Okay.
And got to camera 2, and then they started having me go in the control room and start actually switching the show live my last year here.
Okay, so they're the cameras that we use now, and they are significantly smaller than what you were on. There's camera 3 looking at camera 1 and 2 right
Those
there.
cameras were old when I was here.
Yeah.
These are pretty cool though.
Well, it's just like cameras, because you do a lot of photography, and cameras are a lot different now as to when you were probably in high school even.
Technology's always changing.
Right.
Yeah.
So did you like being moved into the control room?
I liked doing new things and becoming, not necessarily if it was what I wanted to do long term,
Right.
but just learning a new skill and just adding it to my toolkit essentially.
All right. Well, you know what? Let's take a look at a little bit of footage that we've got here, Zane. Years ago.
Here's what we're gonna do. Here's our math, all right?
Oh, okay.
Pick the number of times a week you would like to have chocolate and write that down. We'll give you a little bit of time to work on that one.
There you are.
So I'm gonna add 1763. All right? Does everybody have 3 numbers? Yolanda?
Yes.
Chuck?
Yes.
Marylou? Zane? All right, everybody has 3 numbers, and I am going to just take it that all of the kids at home have 3 numbers as well. The first number is the number of times you desire chocolate per week. The next 2 numbers are how old you are.
Yes.
It worked? It doesn't matter, but it worked, right?
Marylou waving us
And it worked
off
for
there. How
mine.
old you
Worked
are.
for Yolanda's. Chuck, worked out nicely. Zane? All right.
All right, there you
Ellie.
are. There's Mackenzie and Ellie with you also.
Yeah.
Ellie was another one that came in after you and
look at that.
Mackenzie started. There
It's
you
my
are
last day.
in the control room.
Oh, yeah.
Yeah,
Big
many
math
of one of
party.
our many end of year or mid year powwows.
Yeah.
But
holiday
I don't
party
know. That
again.
must have. The holiday party
Yep.
that we had, the potluck. There you are with Mackenzie and a plaque that you guys are holding right there. And you know what? Why don't we have you hold that up to camera 3 right there, and we'll see if the person manning that camera 3 like you and Mackenzie did can get a shot of that. Outstanding student employee, and you can see that you and Mackenzie were the first ones back in 2013, 2014 to lead the way for all other students that have passed through the doors of the Kern County Superintendent of Schools ever since. So Zane, what are you doing now? So I mean, obviously you worked for Do the Math and you went away to school.
Yep.
So where did you go and what were you studying?
After high school, did 3 years at BC and then transferred to CSU Monterey Bay, majored in film. And after I graduated from CSU Monterey Bay, moved down to Los Angeles, and that's where I live right now.
Okay.
Full-time.
And so you majored in film, and maybe Do the Math had a little something to do with that?
Oh, yeah. A lot to do
There we
with
go, right? So we got you on your way.
Yeah.
And so what is your what do you do now in LA?
Do a lot of things. So I went full-time freelance photography and filmmaking in January of 2020.
Okay.
And I'll do anything from being a second assistant on a photo shoot, which means I'll be taking direction from the first assistant setting up strobe lights or setting up stands to all the way going up to assistant editing for video. So using all of the skills I've learned here in school and in my own projects even before Do the Math, put them all together and just threading jobs together and making ends meet at the end of the month.
I was going to say, you're making it work, right? I mean, right in the middle of COVID, January 2020,
Yeah.
you decided
I
to
left a full-time job to
you go to
freelance.
LA, right? I mean, the cost of living more expensive than wherever you were before.
Yeah, yeah.
Right? Having to go, all right, I'm just going to do what I want, what I love to do, and make it work. And
Yeah.
you've been making it work. It's been a year. You've
Yeah.
been successful at it, obviously, and going to keep it going.
Yeah, I mean, I'm very fortunate to have parents that always believed in me and always helped me in everything I wanted to do. And my dad was a professional photographer, still is, at the newspaper for 40 plus years.
Okay.
And then everything I learned here also adds to that and helps me continue to keep making my way down there.
There you go. Well, I'm certainly glad that you are successful now. I'm glad that Do the Math had a small part in that, and that you did kind of, go on somebody's recommendation, like, hey, go check out this TV show at the Kern County office and see what's going on with it. And like I said, you have been an instrumental part of Do the Math during the last 20 years. For one, a student coming in, like I said, you and Mackenzie were the first ones. Ellie followed a little bit right after that. And you guys had major responsibilities here. I mean, of course, you started on camera 3, like, we started on camera 3, we didn't have much to do, but you've got to start somewhere.
Yeah, that's
right?
It's a good lesson I
And
learned.
from small things, big things do come later on.
Yeah.
Well, Zane, all the best to you. Thank
Thank
you for
you.
stopping by. Thank you for coming up
Thank you.
and visiting us at Bakersfield. And I'm sure you'll be able to stop and see some family here in Kern County while you're here.
Always.
And have a great holiday season. And if I'm not mistaken, we might be able to get your brother,
I'm going to try to.
an applied math major, come on the show.
He owes me
and,
a few favors, so we'll see
there
if
you
we
go.
get
Chat a little bit about his math.
Yeah.
All right, thanks for that. That is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we're going to go to the phones. And Raymond, how are you today?
I'm doing good. How are you?
I'm wonderful myself. Now, you're a 6th grade student at Stockdale Elementary, correct?
Correct.
All right, as soon as you're ready, let's hear the problem that you're working on. And Luis, I'm going to have you go over to the board and write down some of the things that Ray says. All right? All right, Ray, read the problem as soon as you're ready.
If you borrow money for a car at 6% interest, how long until your debt doubles if no payments are made?
All right, so Luis, write down, don't let your hand or arm touch the board. So way over on the left. Yeah, go ahead and erase that first. I'm going to have you start way over on the left. Whoop, your other left there, son. There you go. All right, so write 6%. You know what a percent symbol looks like? Oh, you can write it like that. All right, so we've got 6%. And so it just wants to know how long it will take until it doubles, correct?
Correct.
All right. Now, they didn't give you an amount of money, did they?
No, they didn't.
And they didn't give you a period of time either, did they?
Nope, they did not either.
Okay, so is this what's throwing you off?
Yes.
Okay.
Ooh.
So an open-ended question like that is a beautiful question. You can't get a better question, I think, from an instructor than an open-ended one like that. So you're a lucky guy for having something like that thrown your way. So let's start with an amount. Let's start with $10.
$10.
All right. So Luis, as high as you can, write $10. And you just put a dollar symbol next to that, if you would, please. There you go. All right. Ray, I need you doing the same thing on your paper as we're doing this, all right?
Yes.
Ray, do you have a calculator?
You know what? No, I don't, but I will pull one up right now.
There you go. Go ahead and get a calculator because you're going to need that, all right? And what we're going to do is instead of having a ridiculous amount for this car, we're just going to go with $10 because it doesn't matter what the amount of money you use is. It will turn out to be the same.
Okay.
All right, so we could have $10, $1,000. We could have $18,440. All of the numbers will turn out to be the same amount of time, but we're going to use a simple number so that we can keep track of things a little bit easier, all right?
Okay.
Sound good? All right, so what we're going to do is we're going to do this. Would you like to do this in weeks, months, or years? Because they didn't give you any amount of time to do it with.
Let's do weeks.
All right. So what I'd like you to do, Luis, is next to 10, at the end of 10, draw a line from the 10 all the way down to where you are, straight down. Perfect. All right? And what I want you to do is I want you to write on the other side of the line, week 1. So W-E-E-K, there you go. Perfect, week 1, all right? Now after the word week, draw another line. Ray, how would we figure out 6% interest on $10?
Well, the first thing I would do would be, I don't know.
Okay, so what you're going to do, you have your calculator all pulled up?
Yes, I have my calculator pulled
All
up.
right, so put $10 in the calculator.
Okay.
And then you're going to multiply that by 6%. Now, do you know how to put 6% into a calculator as a decimal?
You divide that percentage by 100, and that gives you your decimal.
And so tell me what the decimal would be.
The decimal is 0.06%.
Okay.
Or 0.06.
There you go. All right. So,
With
Luis,
10?
do me a favor. Under 6% that you've got right there, put 0.06. There you go. All right. Now, get rid of the per now, the percent. Well, all we want now are the numbers, 0.06. Perfect. All right. So, Ray, if I have $10 and I have to pay 6% on top of that, what is $10 times 0.06?
$10 times 0.06 is $0.6, which is 60 cents.
Right, 60 cents, all right? So if you owe 60 cents more, what do you owe altogether after week 1?
$10.60.
Good. So Luis, after week 1 on the side, yep, $10.60. That's all right. Yeah, just make sure your hand doesn't touch it. There you go. $10.60. Are you with me, Ray?
Yes, I am with you.
Good. Clear the calculator.
Okay.
I want you to put $10.60 in the calculator.
Okay.
Now-
$10.60. Okay.
Right. So now, instead of multiplying each time by 6% only, we're going to multiply by 1.06, 106%. Do you have any idea why would we do that?
It would instantly give us our total amount, and we wouldn't have to add.
True, it would. It would instantly give us the total because we're taking the $10.60 already, which is 100%, and adding the 6% interest on top of that. All right? So now what I want you to do is you have $10.60 in your calculator. Now I want you to
Yes.
multiply that by 1.06.
That equals 11.236.
All right, now hold on, brother, hold on. Luis, down at the bottom, any place you want, I want you to write 11.236. Now, Luis, if I had that number and I had to round, all right, I don't want 0.236. Will the 6 move the 3 anywhere, or will it leave the 3 the same?
It will move.
Where's it going to move to? What's it going to do?
That means it will be 11.240.
Ray, do you agree with that?
I do.
Yeah, there you go. So 11.236, like Luis just said, would become $11.24. All right? So Luis,
Yeah.
get rid of all of that stuff you wrote at the bottom there. There you go. Just circle it. Whoop, use your eraser end. There you go. Good. Now, Luis, I want you to write underneath 1 week, I want you to write the number 2. Under 1. Good. Now, next to that, I want you to put our total under 1060. Remember, we had $11.24? Good. All right. You with me, Ray?
I'm with you.
All right. So now what do you think you want to do?
I would do the exact same thing, except with 11.24.
Good. So take that, multiply that by 106%, which is 1.06, and tell me what you get.
I get 11.9144.
So what would that be if you rounded it?
That would be 11.91.
There you go. So Luis, put 3 and 11.91. Yep, $11.91. Well, put a 1 after the 9. So after the 9, put a 1. So $11.91. So get rid of your dot, your decimal point. There you go. And put it before the 9. There you go. Nicely done. All right. Ray, you got the idea on how this is going to go?
Yes.
Okay. Now,
yeah.
how many times do you think you're going to have to do this? What amount do you have to get to?
I have to get to at least $20 because
Right.
that would be double.
Right.
of
So
my
how
debt.
many weeks have we done it so far?
3 weeks.
We've done it for 3 weeks, and we're almost at $12, correct?
Correct.
So you're going to have to keep going week by week until you hit at least what?
$20.
$20, all right? So that's what I want you to do. So you've got the way to do it now, correct?
Correct.
So what you're going to do is on your paper, you're just going to continue writing down, like week 4, week 5, week 6, week 7, whatever, and keep multiplying by 106%. And when you hit at least $20, and you're probably not going to land right on it, you'll probably go over, whatever number of weeks that is, that's the amount of weeks it will take to double your debt. Does that make sense?
Yes, it does.
All right, good. I'm glad we could help you out. Keep working on that. And if you want to, give us a call back just to make sure that you've got the correct number of weeks. But for phoning in with that great problem, you've got yourself a pass to Holiday Lights at Com. So congratulations on that. Luis, there's a lot of weird words in math, don't you think?
Yeah.
Have you ever heard just the ordinary word Ray? It's funny that kid's name they just called in was Ray, right? Mm-hmm. When I say Ray, just as a word, what do you think of?
Arrays.
A what?
Arrays.
Arrays?
Yeah.
Okay. Well, you know what? There's a lot of different things that might come to your mind when you think of the word ray. Let's take a closer look at them in today's language of mathematics.
Hi, I'm Marylou, and in today's segment of Language of Mathematics, we have another wonderful word, ray. Well, what does ray really represent? So when we think about that word, we think about sun rays, correct? Or we think about some dude named Ray. But what does ray really represent in mathematics? Well, what ray is, it's one endpoint that continues on forever in another direction. Let's look at what that is. So here I have an endpoint, and then I have the arrow continuing down. So it's going on forever in one direction. So it starts here and goes on forever. Or here we have a ray because it starts here at this point, and then it's going up and continuing on. The arrow tells us that yes, it's going to continue on. And then here's another example. Again, it's starting at the bottom, and this ray is going to continue up top. So again, what does it really look like? How can we use this in math? Here I have a point, and we're going to call it point B, okay? So we're going to just start with this point. From this point, we're going to draw our ray. Our ray starts at point B, and it's going to continue on through C, point C. But we need to label this ray. So we're going to label this ray BC. And again, we put a dot here to represent our labeling. And when we look up here how we label it, you see the little bitty ray at the top of BC? That tells us, hey, that's a ray. We know it starts at point B, and it's continuing on through C. So from point B, I'm going to draw another ray, and my ray is going to go up through point A. So now not only do I have one ray, BC, but I now have another ray, BA. So again, I'm representing it. I have ray BC, and I have ray BA. Oh, that made a pretty picture, didn't it? It actually created an angle. And angles are actually starting with one point, a center point, and it's made up of two rays. That's how we create an angle, by using two rays. So therefore, I can call this an angle ABC. And you notice that I have a little angle mark there, and I've put B in the center because B is my center point. But I also can call it ABC, but I can as well call it CBA. I could go either way, but both ways, as you noticed, B is still in the center. Again, two rays equal an angle. And that is it for our language of mathematics today.
Always something great on the language of mathematics, taking the word that you hear in other contexts, but then seeing how it is applied in mathematics. Just so happens to be that our first phone caller today, his name was Ray, and we had Ray on our language of mathematics. 636-4357 is that phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays. We have another phone call that we will address in a little bit. But right now, we are fortunate enough to have Victor from the Bakersfield Museum of Art in studio with us today. Victor, how are you?
I'm great. How are you?
Excellent myself. So what is your role with the Museum of Art?
I'm an art educator at the museum. I'm a front desk assistant and the volunteer coordinator at the museum.
All right, so that's why you went, because you've got quite a few hats to wear while you're at the Bakersfield Museum of Art. And how long have you been with the museum?
I have been with the museum for 4 years now.
All right, well, you've got something, you're going to work on some art and also talk about ratios. You've got Luis, who's a 5th grade student who doesn't necessarily know a lot about ratios right now, but hopefully with you today and doing a little bit of art, we'll understand a little more. So take it away, boys.
All right. So let me explain a little bit about the project first. We're going to be doing acrylic pour. So it's a fluid technique where you just pour paint onto your canvas here to create a smooth, vibrant, glossy surface. Now ratios come into the effect where we are talking about the consistency of the paint and the pouring medium here when we combine everything. Now in math, ratios are about when you look at how many numbers fit within or contain another number. So when you think about it, for example, if you have 8 oranges and 6 apples in a fruit bowl, your ratio of oranges to apples would be like 8 to 6 in that fruit bowl. But here it's a bit different. It's about how much paint and how much pour medium you have in your cup to create that very fluid consistency will help you create a painting here. So go ahead and choose about 3 different colors of paint. All right. And then I will choose 3 as well, so blue, green, and yellow. I always got to have yellow. Now think of it as this way. We're going to go with our pouring medium first. Now with ratios here for this, you normally go about maybe 1 to 2, 2 to 5, and that's because you think about it as you're doubling your pouring medium to your paint. So if you're about 2 to 5, you're more than tripling your pouring medium here. So go ahead and pour this into your cup here. And let's go for about 3, so count to 5 as you're pouring.
1, 2, 3, 4, 5.
All right. Go ahead and leave that there. And then here with your color here, so we count to 5 there. Now open that. Is it a little open? Here, I'll help you out. Now instead of using the stopper, go ahead and just pour it out into the cup and count to 3 for that one.
1, 2, 3.
Yeah. So we have a ratio of about 3 to 5 there. So it's 3 parts acrylic paint to 4 or 5 parts pouring medium. So go ahead and mix that there. If you have to, you can hold the cup in your hand so you get better control of it. Now the ratios when it comes to this project are always a little tricky and they will always change because it depends on how vibrant you want your color to look, how big of a surface you have, and essentially, do you want it to look more of like this little yellowish color here, or do you want it to be brighter? What do you think about that?
Think lighter.
Brighter? That's when you'll add a couple more drops of this here. So you counted to 3 that last time, go ahead and count to 5 this time.
1, 2, 3, 4, 5.
There you go. And go ahead and mix that. What do you think about that color now? You like that color?
Yeah.
All right. Now you'll go ahead and do the same thing with these other 2, but feel free to remember, keep in mind your ratios here. So let's keep this up to 5 like we did before. Go ahead and count to 5.
1, 2, 3, 4, 5.
Perfect. And go ahead and do the same thing with this one here.
1, 2, 3, 4, 5.
Great. Now with this orange, since it's more of a reddish color, yellow, you have to use much more of it. So instead of the 5, go ahead and count to probably about 8 when you do this one.
Okay. 1, 2, 3, 4, 5, 6, 7, 8.
All right. So if you think about that, when it comes down to your paint and your pour medium, what is your ratio of that there? Of when you counted? Oh, that's very vibrant. So we have about 8 to 5 here for this pouring mixing color here. Now for this one, it's blue. So go ahead and, how many times do you want to pour this in here?
5.
Go ahead.
1, 2, 3, 4, 5.
Perfect. Go ahead and mix that and see how you like that. You like that color? Like the way it came out? Perfect. Now let's see how I come out with these colors here. I'm gonna go ahead and just pour 1, 2, 3, 4. And then 1, 2, 3, 4, 5. Because that's gonna be my yellow, so there needs to be a bit more there. One, 2, 3. Whoops. My green. 1, 2, 3. And my blue. 1, 2, 3. So 3 to 5. 3 to 5 for most of them. That always gives me a proper vibrant color that I like. Now here comes the messy and from my favorite part of the entire project. Now it's up to you. Would you like to wear some gloves for this hand part?
Yeah.
Don't want to get paint all over your... Doesn't matter where the fingers go as long as your hands are covered. Right. Your thumb right in there. Perfect. And I'm used to the mess, so I will not use the gloves right now. All right, so what you're gonna do is with your cups of color, you're gonna then choose where you would like to pour these on here. Don't worry about mixing, that will come very soon. You don't have to use the spoon, just go ahead and just pour it out of the cup. You don't have to use the whole thing either, just wherever you'd like. Perfect. Feel free to overlap colors, pour them into different corners. Use your other 2 cups here. There we go. Yeah. Great. And then the final color. Then, with your gloves now in your hand, you're going to go ahead and pick up whether you like it from this side or this side and just start to move the canvas around so the colors will start to combine and move all over. There you go. Yep, you can even pull it towards you if you want more color over here, over there. Perfect. Even sprinkle it on there, you get more of it. Yeah. And then let's try this one. Here we go with this. All right, maybe I should have done gloves. But here we go. And you always want to make sure you get a consistency of, it's very fluid, very liquidy, but not exactly like water, because then it'll become too transparent and dense. But that is how I often use ratios to create my pouring paintings like I do here. And then it'll dry very shiny, very glossy, and then it'll be a perfect piece to hang up in your home. Yeah? So what did you think of that?
It was fun.
Yeah? So like I said, the ratios will always change. You had about 8 to 5 for one of them, 3 to 5 for one. It's all about the ratios of different pouring mediums to your acrylic paint. And here we go.
So working with ratios, and so this is something that, so what age would you be working at the museum with students with something like this?
Actually, as little as 6 years old, I've had some students work with this type of project. Yeah. And they've had a lot of fun with the different numbers and changing it and different amounts that they pour into their cups. Because it'll give them a more vibrant and much more access to their paint colors.
Yeah, I was going to say, and students may not even realize it, that they are working with ratios, and it's something that they could be using all of the time. It may not fully understand how it is mathematically, but they are using it and grasping it, and something that they can relate, something that they actually made in real life when they start doing ratios in elementary and junior high school.
For sure, yeah. I mean, I never considered I was using ratios either when I was making these types of paintings until I really thought about it.
There you go. There's math in everything we do, Victor.
In everything.
You now see that. Victor, if somebody wants some more information about the Bakersfield Museum of Art, where should they go to find more out?
They can go to our website, bakersfieldmuseumofart.org, so bmoa.org. And if you'd like to be a volunteer for the museum, I'd also appreciate that too. And then come over to our Saturday studio classes that happen every other Saturday as well.
All right, there you go. So it's not a bad deal. You go down, volunteer, do a little bit of art, learn a little something, and have fun at the same time. So Victor, thank you once again for coming in. And thank you to everything that the Bakersfield Museum of Art is doing with Do the Math the past years, and especially this year, our 20th season. We'll be back with more right after this.
Perfect.
This week, Lab TV travels to an Army research lab in Natick, Massachusetts, where scientists are creating very tiny antennas inspired by one of nature's most beautiful creatures, the Luna moth.
The Luna moth can actually locate a mate when the mate is miles away by having this very, very, very sensitive antenna. The female moth actually emits an electromagnetic pulse that's in the IR.
The female sends out an IR, or infrared light wave, and the male's antenna is specifically designed to receive that signal.
The antenna actually collects the light and it directs it towards a probe that's at the base of the antenna. And then that probe sends a signal to the brain.
The moth captures infrared light. Brian and his team are working to capture visible light. Infrared is measured in microns. Visible light is smaller. It's measured in nanometers.
Nanometers are usually compared to a human hair. So you could have, say, tens of thousands of nanometer-sized features around the circumference of a human hair. And the really interesting thing about nanotechnology is that because these features are so small, these materials interact with nature, with light, or with sound, or with really anything in new ways. With light, it turns out that nanoparticles are very, very useful because nanoparticles have sizes on the order of a wavelength of light. They interact very strongly with light.
Visible light waves are very short, only 400 to 800 nanometers. Radio waves can be longer than a meter.
If a radio antenna is, say, half a wavelength of a radio wave, you get a very, very strong coupling of that radio wave into the antenna. The same thing happens with light. So if we can make a nano feature that is on the order of a half of a wavelength of light, then we get this very, very strong interaction.
Brian is making tiny antennas that are tuned to receive light waves, just like your car antenna is tuned to receive radio waves. He's making them from carbon nanotubes.
So a carbon nanotube is really a rolled up sheet of carbon. The interesting thing about carbon nanotubes is that we can control their length. And because of that, we can tune them so that they interact with specific wavelengths of light.
In nanotechnology, the best way to study light is with lasers.
So lasers are a very useful way of studying the interaction of light with materials because they are very, very controllable. You have this very, very intense light source that's highly focusable, that goes exactly where you want it to go, and it's all the same color. So now we know that a material, let's say, interacts very strongly with a red color, or a green color or a blue color. We can choose our laser so that it interacts very strongly right at that particular wavelength. If you illuminate these nanotubes, and if they are the right length, they'll actually couple very, very strongly with light. And with coupling like this, you can actually get near 100% coupling of energy, which is highly, highly efficient. So now the question is, how do we take that energy and do something useful with it?
They have lots of ideas, like converting solar energy into electricity.
We'd like to be able to make the connection between light and an electronic circuit. So we'd like to be able to turn light energy into an electrical charge.
Brian and his team are pioneers in a brand new field. They have a long way to go, but it's very exciting work.
Probably one of the most exciting things is that when we're evaluating some of these materials, many times the response that we get is not at all what we expected. And what I found is that many times what it really is doing is a heck of a lot more interesting than what you actually thought it was going to do. So that's, I think, is one of the most exciting things, is you really never know what you're going to see.
To find out more about light, antennas, and nanotechnology, check out labtvonline.org.
Always something new and interesting to learn with that series. We want to say thank you to Luis for coming in this afternoon, a 5th grade student from Highgate Elementary, and used to be a Bulldog at Buena Vista, huh?
Yeah.
All right, well now you are a, what was it, the Huskies you said, right, at Highgate? All right, so did you like that art project? That was pretty cool, wasn't it?
Yeah, it was fun.
There you go. I think you might be able to take your art home with you too, I think, unless they plan on exhibiting it, at displaying at the Museum of Art, and then you can sign it, and you could be a famous artist after that. Anyway, we're going to go to the phones once again, and I know we've got a 7th grade student, Brianna, how are you today?
I'm good. How are you?
I'm wonderful myself, thank you. What school do you attend?
Downtown Elementary.
Downtown Elementary, right around the corner from Do the Math Studios, as a matter of fact. Brianna, read the math problem that you're working on.
It says Charlie runs at a speed of 3 yards per second. About how many miles per hour does Charlie run?
Good. So have you got some paper handy?
Yeah.
All right, good, because I'm going to need you to write down some things. So what I want you to do is I want you to take a look at the board, and I want you to write down exactly what I've got on the board already. So I've got 3 yards over 1 second. And then you're going to go times blank seconds over 1 minute. And the next part is times blank minutes over 1 hour.
Blank minute over 1 hour.
And then times, and then 1 mile over blank yards.
1 over blank yards. Okay.
All right, so Brianna, one last thing I need you to do is go to your TV or computer and turn the volume all the way down.
Okay.
And you're all set now?
Yes.
All right, perfect. This is going to be a little easier to communicate that way. So, Brianna, you can see that at the beginning she goes 3 yards in 1 second, correct?
Yes.
And we want to figure out miles per hour.
Yes.
And this is how we're going to figure this out, all right? So if we take a look at the next part, it says blank seconds over 1 minute. Now, how many seconds are in 1 minute?
60.
All right, Louise, put 60 up there where it says blank seconds. Does that make sense to you, Brianna, that there are 60 seconds in 1 minute?
Yeah.
Okay, now take a look, Brianna. What's the next part? We have something minutes over 1 hour. What do you think is going to go there?
60 minutes over
right.
1 hour.
Good. So, Louise, go ahead and put that up there, 60. Now we have 1 mile is to something yards. Now, do you know off the top of your head how many yards are in 1 mile?
No, and I don't have the chart.
Do you know how many feet are in a mile?
5,000 something.
Yeah, 5,000 something is correct, all right? Do you have a calculator with you?
Yes.
All right, so it's 5,280. So in the calculator, put 5,280. And I want you to divide that by how many feet are in a yard?
How many? 3.
3. So do 5,280 divided by 3 and tell me what you get.
1,760.
Good. So Louise put 1,760, 1760. Oh, 60 instead of 16. Well, you can't use your finger. Yeah, use the eraser. There you go. So erase the 6 and put 60. So I know on a whiteboard we could use our finger to erase, and it's kind of a habit we all got into. So Brianna, does that make sense? There are 1,760 yards in 1 mile.
Yes.
Okay, so now what we're going to do is we're going to start eliminating units. Okay, so do we see yards anywhere on the top and yards anywhere on the bottom?
Yes, at the beginning and the end.
Good. So Luis, don't cross out the 3, just cross out the YD standing for yards. Good. And do the same thing down on the bottom where you wrote the 1760 yards, just cross out the YD for yards. Perfect. Brianna, what else can we cancel out? Because it has to be the same on top and bottom.
The 2 minutes and the 2 seconds.
Good. So Luis, where it says seconds, SEC, cross that out on the top and cross it out on the bottom. And you also said minutes, correct, Brianna?
Yes.
All right. So do you see where it says minutes, MIN? Very good. Now, Brianna, what units are left?
Just hour and mile.
Right. And how would we read that as a fraction? What comes first, the top or the bottom?
60 over 1 hour.
Right. It would be miles per hour, correct?
Right.
Okay. So now we have to deal with all the numbers. All right. Let's look at the bottom. That's easier to do. Go right across the bottom from left to right. What's 1 times 1? We don't even need that, do we?
No.
No. So Louise, cross out all of the 1s that you see. Does that make sense? We don't need 1s, do we?
Right.
Okay. And under 60 seconds, see that 1 minute and the second one? There you go. Now do me a favor, Luis, go back to where you wrote 1760 and under it, write 1760 again. Because we're going to need that 1 because it's not by itself, it's with another whole number there. All right? So, Brianna, do me a favor. With your calculator, I want you to multiply the numbers on top. Go 3 times 60 and tell me what you get.
180.
Now times that by 60 again.
10,800.
All right. So on the top number of your fraction bar, you're going to write a new fraction bar. You're going to write 10,800. That's what you got?
Yeah, 10,800.
Okay. Draw your fraction bar. And now the number on the bottom, if we multiply all of the numbers on the bottom, well, there's only one number left, isn't there? What number is left on the bottom?
The only number, 1,760.
Good. So I want you to, in your calculator, go 10,800 divided by 1,760. And tell me what you get.
1.136. Do I need to round this up?
Well, hold on there. Let's try this again. You said you went 3 times 60 times 60. You got 10,800, right?
Yes.
Okay, then you're going to go divided by 1,760.
So that'd be 10,800 divided by
1,760.
1,760.
And then tell me what you get again, because I've got something a little different.
0.6136336.
Okay, so you may put a decimal in there someplace, but do you see where it says 613?
Yes.
Okay, that's what we want. It's going to, so Luis, somewhere down at the bottom, nice and big, put 6.13. So that is the miles per hour that you're going to be going. Now, do you have to round it to a certain spot?
Yes.
To the nearest whole number or tenth, or what was it?
I don't. It doesn't say anything about rounding.
Okay, good. Well, then just leave it at 6.13 miles per hour, and you can also put that would be 6 miles per hour if you had to round it. Does that make sense?
Yeah.
All right. Well, thank you for calling in today, Brianna, and for phoning in. You've got yourself a pass to go see Holiday Lights at Come. So nicely done. You, young man, have been pretty busy, haven't you? Well, you know what? Because you've been doing some great work today, you are going to be receiving a meal courtesy of our friends at Chick-fil-A. So congratulations on that. And you've never been to Chick-fil-A, have you? Oh, I'm telling you right now, young man, you are going to be loving that Chick-fil-A. As soon as you get some of that into your stomach, you're going to go, oh, I need to go back again. You think so? I promise you. All right. Why don't you go ahead and put that marker back up there? You and I are going to play a little game here. All right? So we have all of the numbers 1 through 10. All right? And it doesn't really matter. I mean, so that's going to be the 9, and that's the 6. Okay? And then we have all of our other numbers here. All right? So here's what we're going to do. You and I are going to play a game. All right? We're going to see who can get the lowest number at the end of the rounds. Okay?
Okay.
So here, I'll go first to kind of show you what we're going to do. I'm going to roll the dice. What did I get?
6 and 1.
I got a 7 altogether, right? So I want to take numbers that will add up to 7. Okay? Now, what could I take?
You could put 4 and 3.
I could take 4 and 3. Is there any other thing I could have done?
5 and 2.
I could have done 5 and 2, right? Anything?
6 and 1.
I could have done 6 and 1. Could I have just taken 7?
Yes,
I
yes,
could
you
have,
can.
right? There's a lot of things I could have done. I want to get rid of a lot of them at once, right? So I'm going to go, you know what? I'm just going to go 4 and 1 and 2. Does that make sense?
Yes.
All right. So now I'm going to roll it again. And I only have these ones I can use. Now I have 6.
Yeah, 6.
What can I take away?
You could take away 6.
That's it, right? We'll do it again. I have 3.
3, you could take away 3.
That's all I can do, right? I better get some high numbers here. What have I got?
9.
What can I take away?
You could take away 9.
That's it, right? So these are the only ones I have left, right? What can I take away?
You could take away 9, but
Is there any way to make 9? No.
No.
So I'm left with 5 and 7 is 12, and 8 is 20, and 10 is 30, right? So I'm left with 30 points there. It's your turn now. So you roll the dice.
6.
You have 6. What would you like to take away?
I would take away 6.
Good. Roll it again, because you can't take anything else. You already got 6. Roll it again. You have 5.
I could take away 5.
Good. Roll it again, because you already got rid of the 5. You can't take any more. Ooh, 12.
I could take 10 and 12
Good.
and 9 and 3.
Well, you can't take them both. You can only do it once. So you get the idea of the game? You're going to win already because you already have fewer points than 30. You're going to win, all right? Did you learn a little something today? Did you have fun today? All right, good. You know what? Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.